With the increasing scarcity of water resources and the fact that there is no new water, water reuse is becoming more important to food production and sustaining livelihoods. To take us on this journey, examining how technology and innovation can create a sustainable, efficient use of food production, is one of the directors of Green Age Farms, a company that was founded 6 years ago with the desire to provide a sustainable, simple, resource-efficient method of agriculture. Please let's welcome Ms. Faarriah Khan.
Greetings to all officials of the Ministry of Public Utilities and other government agencies, the Water and Sewerage Authority, the Water Resources Agency, specially invited guests, and other presenters. I am Faarriah Khan from Green Age Farms. Green Age Farms is an agricultural company that provides agricultural supplies and hydroponic systems, where we provide training and guidance, making it easy for persons to grow their own food, whether it be for home or commercial use. Today, I will be presenting on water conservation in hydroponics. So, this is the outline of what I'll be discussing today. So, I'll be touching briefly on watering technique used in conventional farming. What is hydroponics and what are the different types of hydroponic systems, and water conservation in hydroponics. So, in conventional farming or field farming, crops are grown in the soil. So, the plants normally cover a large area of land, typically acres of land. So, the method commonly used to water plants grown in this way is spray irrigation. So, spray irrigation is a method used to supply water to an area in a way that mimics rainfall. Based on where it is used, residential, industrial, or agricultural, the system may consist of pipes, hoses, pumps, valves, and sprinklers. So, in this picture, this is an example of spray irrigation being used to water a commercial farm. So, as you can see, the spray nozzles are distributed throughout the farm, and the water is sprayed in a very uncontrolled way. So instead of the water wetting just the root zone of the plants, the water ends up in between the plants, and there's a lot of wastage. So due to the random watering and wide land area that this method covers, there are a lot of downsides with respect to water conservation. Firstly, there is increased runoff. Plants are fed more than enough water. The excess water passes the root zone, the water is wasted, and it then goes into the ground. There is also loss of water due to evaporation, since the water from the sprinkler system is exposed to the sunlight. There's also drift taking place due to wind. Overall, this leads to increased water usage. The soil in this type of farming is also exposed to the elements, which means that moisture is lost very quickly from the soil. This leads to more frequent watering of crops to prevent the crops from drying out. This leads to more water usage. With conventional farming, the roots need a larger area to search for nutrients in the soil, since the nutrients are not being fed in a soluble form directly to the roots as in hydroponics, which I'll be discussing a little later in the presentation. The spray irrigation system therefore needs to cover a larger area, which leads to excess water usage and runoff into the ground. So now we'll get into hydroponic farming. Hydroponics is a method of farming whereby food is grown without soil. The nutrients are fed to the plants in a soluble form directly to the roots of the plants. There are different types of hydroponic systems. There are two main types: non-recirculating and recirculating hydroponic systems. So different types use growing media in place of soil, such as coco peat, rockwool, expanded clay, perlite, etc. So these are the two main types of hydroponic systems. Hydroponic systems can be either recirculating or non-recirculating. With recirculating systems, the nutrient solution is sent to the plants, then back to the nutrient tank in a continuous cycle. So in this schematic, this is a type of recirculating hydroponic system. It's known as nutrient film technique, or NFT for short. So in this schematic, the system consists of a reservoir which holds the nutrient solution. It also consists of a water pump which delivers the nutrient solution to the plants via irrigation lines. So the nutrient solution enters the PVC channel, in this case, at the start, and wets the roots of the first plants, and then it continues further downstream, wetting the roots of the other plants. Now, at the end of the channel, the water is collected and returned to the reservoir, where it is recycled. So the nutrient solution in this system is constantly recycled and reused. So there are different types of recirculating systems. In this schematic, this is NFT, but there are other types such as Dutch bucket, deep water culture, etc. So now we look at water conservation in recirculating systems. So as I mentioned previously, the water is recirculated in the system, which minimizes waste or runoff. The roots take up just enough nutrients required from the nutrient solution, and the rest is returned to the reservoir to be reused. Based on the number of plants and the size of the reservoir, the solution in the reservoir can be reused for several weeks. Due to the nutrients being fed directly to the roots, the plants can be grown a lot closer together. This is the case since the roots do not need a large root zone to search for food as compared to plants grown in soil. The infrastructure used in these systems are therefore designed to be more confined, and the water usage more controlled as a result. So, for instance, in the NFT system seen here, PVC channels are used, which is very small and confined since the roots do not need a large area to grow in, since the nutrients are already in a soluble form and is delivered directly to the roots of the plants. So this is another example of a recirculating hydroponic system called Dutch bucket system. So the same principle applies, but instead of PVC channels, we're using Dutch buckets. There's also the reservoir with the nutrient solution, and the water pump delivers the nutrients via the irrigation lines to each plant. The excess is collected in a header, and it is returned to the reservoir to be reused again. Deep water culture is another type of recirculating hydroponic system, where the roots are completely submerged in the water and an air pump properly aerates the nutrient solution. So now we go into the other type of hydroponic system called non-recirculating hydroponic systems. So non-recirculating hydroponic systems, or drain to waste, used a timed watering to deliver a precise amount of nutrient solution to the plant a couple times per day, where just a few excess drops of solution leave the system. This can be collected and used elsewhere. So this schematic also gives an overview of the non-recirculating system. So it also consists of a reservoir with the nutrient solution. There's a pump which delivers the solution to each plant via drip lines, and the pump is connected to a timer. The timer is not shown in this schematic, but the pump will be connected to a timer, and you can set the timer to come on twice a day or 3 times a day based on the type of plant you're growing and how much water is needed. Okay, so again, non-recirculating systems. Over here we have eggplants being grown in grow bags. We have a header that comes from the reservoir and the pump, which delivers the nutrient solution to each grow bag via the tiny drip line seen here. So the water delivery system consists of irrigation lines, valves, drip emitters, timers, etc. to efficiently deliver nutrients to the roots of the plants. Through the use of timers and drip emitters, the water flow rates to each plant can be precisely controlled and set. This system will therefore minimize wastage of water. As discussed with recirculating systems, the plants can be placed very close together since the nutrient delivery system is very targeted to the roots. Less space is required and a more efficient use of water. With vertical hydroponic systems, water is used even more efficiently since the nutrient solution is fed at the top level and trickles down to the lower levels. The exposure of the water supplied to sunlight and wind is very minimal, which minimizes loss of water due to evaporation and drift. So over here is an example of a vertical hydroponic non-recirculating system. So from the picture, you can see the overhead irrigation lines, and then there's a smaller drip line that goes to the top of each tower. So the drip line delivers nutrient solution at the top, and then it trickles down to feed the plants in the lower levels. So one drip line can feed a lot of plants as shown in this tower. So as we near the end of our presentation, I'd just like to recap what was discussed. So I think we can all agree that hydroponic farming saves water. And here is why. The water is recycled and reused, as we saw in the recirculating and non-recirculating hydroponic systems. Nutrient solution is directed to the roots of the plants. Water supplied is not exposed to sunlight and wind, minimizing water loss due to evaporation and drift. Plants can be grown a lot closer together, allowing for a more controlled, efficient use of water. The design of the systems include timers, drip emitters, etc., which helps to control the quantity of water delivered. So thank you for allowing me to present here today. Hope the presentation was very informative. Thank you.
Thank you very much, Ms. Khan.